Okay, hey subscribers, welcome back. So I'm going to try something a little different today, and if I'm going too quickly, there's no class here, so if I'm going too quickly, if I ask you to do something, just press pause, do it, and then I'll show you how to do the problem. For instance, this warm up. Go ahead and press pause to do these two problems right now. I'll read them for you if you'd like. A triangle has one side of 7 meters and another of 14 meters. Describe the possible lengths of the third side. Give all possibilities. They're looking for an inequality here. That's your hint. And then list all the angles. They're giving you the lengths of the sides, and they're asking you to list the angles in order from smallest to greatest. So go ahead and press pause if you haven't already. Okay, so the two lengths are 14 and 7. So we take the two numbers, we add them, and we subtract them to find our boundaries, just like we did on the Gizmos learning activity. These are our boundaries, 7 and 21. So 7 is less than x, and x is less than 21. To list all the angles from the smallest to the largest, the shortest side is across from the smallest angle, so angle B goes first. The next shortest side is 7, and C, angle C is across from angle 7, so angle C is next. And there you go. All right, so go ahead and write down this vocabulary. For similar polygons, we're going to start talking about similar polygons, similar figures, similar triangles. Okay. In order for two figures to be similar, their corresponding angles need to be congruent, which they were also congruent in the congruent figures. Okay, but now the corresponding side lengths need to be proportional, like I explained in my previous video. And a scale factor of two similar polygons is the ratio of the lengths of the two corresponding sides. So if I draw two triangles here, this angle corresponds to this angle, and see they're congruent. This angle corresponds to this angle, and they're congruent. This angle corresponds to this angle, and they're congruent. Okay? So the ratio of the lengths of the sides, okay, from length of this side from the length of this corresponding side to this side is for every 1 here, there's 2 here. Okay? This ratio should be the same for all those sets of corresponding sides. So these two sides correspond to each other. They should also have the same scale factor, the same ratio. For every 1 here, there's 2 here. Okay. So now in the diagram, they tell us that triangle ABC is similar to triangle DEF. Okay, that's the symbol for similar, and you need to know that. So ABC is similar to DEF. Okay, list all the pairs of congruent angles. Well, angle A is the first angle in this name. Angle D is the first angle in this name. So those two angles are going to correspond to the same position in the triangle, and they're going to be congruent. So angle A is going to be congruent to angle D. Angle B is going to correspond to angle E, and they're going to be congruent. Angle C and F. Okay, so B and E, and then C and F. I'm going to write a little thicker just to make sure you can see. All right, so now that we have shown that all their corresponding angles are congruent, okay, and we've met this requirement here for those figures to be similar. The corresponding angles are congruent. Now we need to see if all their corresponding side lengths are proportional. So let's look. Does this ratio, 10 to 15, is that going to equal the same ratio as that side to that side? Is that going to be the same ratio as, they should all be the same ratios when we simplify them. Otherwise, the two triangles are not going to be similar. So AB to DE is 10 to 15. When we simplify, what do we get? I want you to try that on your calculator. BC to EF, 8 to 12. Try that. Math frac. Make sure you know how to do math frac. And then CA to FD, that's 12 to 18. Okay, so we simplify. We know that 5 goes into 10 twice and 5 goes into 15 3 times, right? So 8 divided by 4 is 2, and 12 divided by 4 is 3. So we're getting 2 to 3 as our scale factor or our ratio for each of the sides. So all the sides, we just checked that the ratios of the corresponding side lengths are equal. C, last thing we're going to do is we're going to check the ratios of the corresponding side lengths in a statement of proportionality. And all that means is we're just going to write these ratios down here and say they're equal. Okay? So we could write, they probably want A, B over D, E, is to B, C over E, F, and that should equal CA over FD. Okay. So we've got 10 to 15 is going to equal 8 to 12 is going to equal 12 to 18. Yay, 2/3 equals 2/3 equals 2/3. All right, so I want you to go ahead and try this checkpoint. They tell you that the two triangles are similar. Triangle PQR is similar to triangle XYZ. List all the pairs of congruent angles. So go ahead and do that. And then write the ratio of the corresponding side lengths in a statement of proportionality. All right, so listing all the congruent angles, we have angle P is congruent to angle X, right? Angle Q is congruent to angle Y. And R corresponds to Z. Angle R is congruent to angle Z. Okay. And now we're going to write all the ratios of the corresponding side lengths. Okay. So most of the time I tell you, you have to have a figure, you've got to have a diagram. They didn't draw it for you, you need to go ahead and draw it yourself. But in this case, how they've named the two triangles really gives us all the information that we need. We could have a diagram and say, okay, PQ corresponds to XY. Okay, so PQ is to XY as QR is to YZ. RP is to ZX. Okay? Or we could just use our similarity statement, because we know first two letters are PQ, those are going to correspond to XY. The next two letters are QR, those are going to correspond to YZ. RP, ZX. Okay? And we answer that one. All right, so I have this already filled in. So I would like you to go ahead and try this problem. Determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. I'm going to have to help you with that, with of ABCD to JKLM. So try your best right now. Go ahead and press pause, do what you can, and then turn it back on. All right, so let's go ahead and check all the angles. So angle C is congruent to angle L. Angle D is congruent to angle M. Angles A and J are right angles, so they're going to be congruent. So the corresponding angles are all congruent. Side lengths, we take a look at their ratios. When we simplify them, they're all 4 to 7, 4 to 7, 4 to 7. So now that we have determined that all of the corresponding angles are congruent and all the corresponding side lengths are proportional, now we know that the two figures are similar. So we are going to write a similarity statement and find the scale factor. So the ratios are equal, corresponding side lengths are proportional. Okay, so AB, CD is similar to, now since we started the name of this figure at A, we're going to have to start the name of this figure at J, because A corresponds to J. J, K, L, M. And the scale factor is 4 to 7. You can really use any of these ratios. You just find two sides that correspond to each other, look at the ratio and simplify it, okay? Where you have to be careful with the scale factor is whatever figure they say first is the number you need to put first. So in this example, if they had said the scale factor of, and they had switched these, and they had said JKLM to ABCD, then this ratio would be 7 to 4, not 4 to 7. Okay? All right, so give you a minute, see if you can try this problem out. Press pause. So in the diagram, they tell us that triangle BCD is similar to triangle RST. And it's nice, they've got the two triangles in the same direction here. Most of the time, one of them has been rotated. So the triangles are similar, so the corresponding side lengths are proportional. BC, where's BC? BC corresponds to RS, and ST corresponds to CD. All right, so let's go ahead now and write a proportion, substituting the values that we know. So BC is 12, oh, we have that. RS is 24. CD is 13. And ST is our unknown. So then we would cross multiply and divide. And do I even have this done? I do. So this is going to be 12 times x equals 13 times 24. Divide both sides by 12. And this is 312. When you divide both sides by 12, you get 26. And they've only asked you to find the value of x, so you're done. No substituting. All right, what is the scale factor of? They're saying LMNP to FGHJ. So here's LMNP and here's FGHJ. So we need to find two sides that correspond to each other by looking at our similarity statement here and simplifying that ratio. Okay, so where's F? Oh, FGHJ, looking at how they named the two figures. LMNP, I haven't rotated a figure, so that's good. All right, so I'm going to go ahead and use that 15 and that 12 because those two sides correspond to each other. See, I just decided to do J or JH, so that'd be PN. Now, they said LMNP to FGHJ. So I'm going to put 12 to 15 and simplify it. If they had said, what's the scale factor of FGHJ to LMNP, then I'd be simplifying 15 over 12. All right, so take out your calculator, you do math frac, you see that 3 goes into 12, or 12 divided by 3 is 4, 15 divided by 3 is 5, so it's 4 to 5. Done. Find the value of x. All right, so now we have to write a proportion with one unknown. I'm going to use this ratio here. That's my scale factor. You can use 12 to 15. 12 to 15. 12 is to 15 as x is to 40. I'm going to use 4 is to 5 as x is to 40. Right? So this is 160 equals 5x. Divide both sides by 5. Let me give you a chance to make sure you've done this for a couple seconds. It's asking for the value of x, so how many times does 5 go into 160? And that's 15, yeah, done. Okay, how many more do we have to do? A little bit more. All right, so what this is saying is that if you have a scale factor already, so I'm just going to make up some numbers for the lengths of the sides here. Okay, so let's say I say this length here is, I don't know, 1 and that's 2. And this looks like it could be maybe the same length, so that's 1 and that would be 2. So the ratio here, there are similar figures. So the ratio is for every 1 here, there's 2 here. So let's say I make this length, looks a little longer. I don't know. Let's say I make this length 2. For every 1 over here, there's 2 here. So if I make this 2, this has to be 4. And, I don't know, 2, 4. This is twice as big, the lengths. So if I were to find the perimeter of this figure, that's going to be 1 plus 1, 2, 4, 6. Okay? And the perimeter of this figure, 12, when I simplify it, I'm just going to get the same scale factor that I would if I was looking at just one corresponding set of sides. That's all this is saying. Okay? 2 polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. And we've already been over what scale factor is. So try to do this problem, press pause, and then come right back. In the diagram, triangle FGH is similar to triangle JGK. So FGH, it's the big triangle, JGK. So I separated the 2 triangles, and I redrew the small triangle right here. So here's J, K, and G. The height of the triangle there is 14, and this length is 10. And then I redrew the big triangle separately. F, there's H, and there's G. This length is 16, and we don't know this height. Okay. So those 2 triangles are similar. Find the length of the altitude of GL. Okay, so here is my unknown. So you can write GL, or I'm just going to put X as my unknown. So now really all I need to do is make a proportion, because I know these 2 sides are going to be that proportion, or that ratio. It's going to be the same as this ratio. So, and there are different ways to write proportions, but I'm going to write, you can, actually let's go ahead and simplify this too. It says first, find the scale factor at FGH to JGK. So to find the scale factor, we're going to simplify this ratio. FH is 16, JK is 10. Okay, so 2 goes into 16 8 times, 2 goes into 10 5 times. So it's 8 to 5. Notice it's 8 to 5 because they said triangle FGH to JGK. Okay, otherwise if they said JGK first, it'd be 5 to 8. So because the ratio of the lengths of the altitudes is similar in similar triangles is equal to the scale factor, you can write the following proportion. So 8 is to 5. So 8 is to 5 as X is to 14. Cross multiply, divide, and you should get 22.4. So normally I would write, all right, so normally I'd write 5, where am I? X equals 22.4. Yeah. And then since they're asking to find GL, we really should then write GL equals 22.4. There we go. All right, last thing we're going to do is the checkpoint. So I'll give you a minute to make sure you can do this problem. Closing task. The 2 triangles are similar. Notice one of them's been rotated now. A lot of your problems are going to look like this on your quizzes and tests, and even on the SOLs. All the triangles are not always going to be facing the same direction. It makes things more complicated. So write a similarity statement and find the scale factor. My hint is to first redraw the second triangle. So I would redraw that in the same direction as this one. So press pause, do the problem, and I'll show you the answer. All right. So I redrew this triangle, okay, in this direction. So now, how did I know? Because they didn't name them. Well, if the side that's across from the hypotenuse, or that's from the right triangle, is the hypotenuse, okay, 25 has to correspond to 10, right? The other two sides are 6 and 8, and then these are 15 and 20. Well, 15 is smaller than 20, and 6 is smaller than 8, so it has to be this direction. Now I can write a similarity statement, and however I choose to name my first one, I chose to name this one X, Y, Z. So now I have to name the second one P, Q, R. Okay, if I had chose to name this one Z, Y, X, then I would have to name this one R, Q, P. All right, so there's a similarity statement. And now I'm just going to check to see if all the sides are proportional. So I'm going to look at each of the ratios. It's much easier to locate now. 15 corresponds to 6. Simplify that ratio. Then 20 corresponds to 8. Simplify that ratio. And then the last set corresponding sides are the 25 and the 10. Simplify that. We have the same ratio, so there's your scale factor. That's it. Did they say? Yeah, in this problem it doesn't say the scale factor of one triangle to the next, so you can write it either way. You can say 5 to 2 or 2 to 5 because they're not clear about what they want. All right, that's it. Thanks for watching.